All right, you are welcome again. Today we are talking about relativity in physics. Okay, now let's take a look at this question. The average lifetime for pi meson with a speed of 0.95 c is measured to be 6 times 10 raised to power minus 6 seconds. Compute the average lifetime of the machine in a system in which they are at rest. Okay, so this is a question given to us to calculate the average lifetime of the machine in a system in which they are at rest. Okay, now let's go. Solution. We say that the time measured in a system in which the machine are at rest is the proper time. Okay, now we denote proper time with this. Okay, good. Now what is the formula we're going to use? We know that time dilation is given as proper time all over square root of 1 minus v squared all over c squared. Okay, and then when we make the proper time the subject, we're going to say that proper time is equal to time dilation open bracket 1 minus v squared all over c squared in bracket 1 all over 2, which is the same as saying square root of 1 minus v squared all over c squared. Okay, good. Now we say that the proper time is going to give us the time dilation multiplied by square root of 1 minus v squared all over c squared, right? Good. And then the time dilation given to us is 6 times 10 raised to power minus 6. And then the velocity v is given as 0.95 c. And then c is the same as c. Okay? Good. Now, since we know some of these values, right, let's compute them. So we're going to say that proper time is equal to, now for the time dilation where we have 6 times 10 raised to power 6, we'll write it. Now square root of 1 minus, then the v is 0.95 c, right, in bracket squared all over c squared. Now in this bracket inside the square root we have 0.95 c squared. So let's distribute the squared. It's going to give us 0.95 squared times c squared, right? Good. That means here we have 6 times 10 raised to power minus 6 times square root of 1 minus 0.95 in bracket squared times c squared all over c squared. So c squared in the numerator, we cancel c squared in the denominator, right? So we'll be left with square root of 1 minus 0.95 squared, right? Good. Now let's go. When you take the square of 0.95, it's going to give you 0.9025. Okay, now let's go. That means we have 6 times 10 raised to power minus 6 square root of 1 minus 0.9025. Okay, so when you say 1 minus 0.9025, it's going to give you the square root of 0.0975. So here we have 6 times 10 raised to power minus 6 times square root of 0.0975. So when you take the square root of 0.0975, it's going to give you 0.3122. Okay, now we have 6 times 10 raised to power minus 6 times 0.3122. Multiply this, it's going to give us 1.87 times 10 raised to power minus 6 seconds. All right, good. So we say that the average lifetime of the machine in a system in which they are at rest is 1.87 times 10 raised to power minus 6 seconds. All right? Yes. Thank you very much. Let's take another example.